Alrighty. Okay, hello everyone. Today we're looking at some graph questions and some irrational number questions. Some irrational questions around irrational numbers. So a bit of a mixed bag today. We'll just get stuck straight in. T Formula is with me today.
Hello everyone.
Just a sec, I need to rearrange something. Okay, there we go. Alright. Okay, so we have a question on the screen. It says, think about the graphs of the following 6 equations. Y equals 2x, y equals 5, x equals negative 1, y equals x squared, y equals x take 1, and x plus y equals 8. Which 2 graphs pass through the origin? So let's tackle that one first, I guess. Just kind of a starter question here is seeing how you can interpret graphs. So which of these graphs would pass through the origin, meaning through 0, 0? Okay, so you need to know something about straight line graphs, and also we have a quadratic here as well. So what means, the question I would ask first, I don't know about you, T Formula, but the question I would ask is, what means that a graph will not pass through the origin? What affects that? In terms of, if you think about the y-intercept, if we think about the general equation of a straight line, y equals mx plus c, which part of this general equation affects where the straight line passes through the y-axis? That would be the first question I ask. And hopefully you say, I know y(mx plus c), I know m is the gradient, and plus c is the y-intercept. So then you can look at these equations and say, let's look for the plus c. Where's the plus c? So y equals 2x doesn't have a plus c. In other words, that means this plus c is 0. So this straight line is going to pass through the origin. We should have also, I guess, talked about the origin. What does that mean? The origin is 0, 0. Origin is at 0, 0. So y equals 2x. The plus c is 0. So, a is going to pass through the origin. Can we find other straight line graphs with a plus c of 0? Well, this one here, f, looks a little bit different. It doesn't look like this y equals mx plus c. But we can rearrange it. So if we take that x over to the other side, so x plus y equals 8, we can rearrange as y equals negative x plus 8. That plus 8 means it's going to pass through the y-axis at 8. So that, excuse me, that is not going to pass through the origin. So f is not an option. B is also an option. Is not an option because we have the plus c. We don't actually have any mx part of that line. We just have the plus 5, which means the line's excuse me, got something in my throat. The line's going to be a horizontal line going through the y-axis at 5. C is going to be a vertical line. D is a quadratic. It also doesn't have a plus c. We'll talk about that a bit more later, but you can think of this quadratic as passing through the origin because it doesn't have anything affecting that quadratic, moving it away from the origin. So D is also passing through the origin. Excuse me, I've got really something in my throat. And then E has a plus c of negative 1. So that's going to be passing through the y-axis at negative 1. So E is not an option. So here we get A and D. according to my working out. Do you agree, T-formula?
Yeah, I agree. I think I've just realized this is a new interface, so I'm hoping I can work it all. But my method would be I mean, yours is very coming from a point of view where it's quite, you know your stuff and you can rearrange all of this, but there may be a more easy method to just get by because if it goes through a particular point, the equation will be satisfied by those values, right? So x equals 0 and y equals 0. And if you put that into any of these, if it makes sense, then it's on that line. And if it doesn't make sense, it's an absurdity. It's not on the line. So you take D, for example. If
Nice.
you put in 0 and 0, you'll get something that makes sense. 0 equals 0. But if you put it into C, you'll get 0 equals minus 1. So it certainly doesn't work.
Oh, that's nice. I like that method. Cool. So two different methods to answer these questions. That's cool. Okay, question 2. Which graph is parallel to the x-axis? What does that mean to be parallel to the x-axis? That means it must be a horizontal line. Well, I kind of already gave the game away before, and I said B was a horizontal line. Can we see any other horizontal lines here? Well, what would that mean if we look at the equation of the line, y equals mx plus c? Remember we said m is the gradient. A horizontal line basically has a gradient of 0. So we want that coefficient of x to be 0. In other words, this won't be there. This mx plus c won't be in the equation at all, right? Because we don't have any gradient, or the gradient is 0. So the only equation here where x doesn't exist, where there's no mx part of the straight line, is b. Okay, so b, according to my estimation, is the only graph in question 2. Do you want to take the next two, sir?
But I was just trying to, because I previously looked at it from a coordinate point of view. I was trying to think about what that would mean again from a coordinate. It's actually very difficult, but I think what it means is no matter what x value that you put in, that the y value will always be a constant, like it will always be the same. I think that's from the coordinate point of view. And that would be probably a lot easier if x wasn't even in the picture. And therefore B would be the one, wouldn't it? Because you'd be putting in, it doesn't matter what x is, y is always going to be the same thing.
I see.
I'm just trying to give it from a different angle.
Yeah, it's
Which
good.
graph is not a straight line? Well, a straight line. You know, this is a good thing to ask in a class because then you're like, okay, we'll get some feedback. But to attempt a lecture, here we go. A straight line is something that won't vary as it continues to change. So it will be something moving and changing at a consistent rate. And you've got polynomials in the form something like this. I guess we'll use C. And you're thinking about what the effect each of these has. Well, each of the terms that we add on has a different effect. If we start with a constant, we have a straight line like this. And then you go to add a variable, you could be going either way like this. And then you add in your squared term, and you're going to be changing as the change continues. So I would say I'd be looking for the exponent to answer this question. And I guess it's fair to say a little bit of knowledge about graphs. I think it's fair to say that you should know that y equals 5 is something that's going straight across in line with the 5, and that x is going straight up. So I'm going to go with, for these straight lines here, 2x. I would love to open it up to people and say, like, what would you go for? A, B, C, or D? Like, put your letters in the chat. See if you can beat me to the end, because you know I'm a slow explainer. Y equals 2x. Definitely going for that one because it's a plain old x. We want to be avoiding the x squareds, really. That's what I'm looking to avoid. Because even though it's going straight up, it's still a straight line. Y equals 5 is a straight line. X equals -1 is a straight line. It's going upwards though. So I'm going to go for that one. Y equals x squared is the parabola, it's got that curve to it. So it's definitely not that one. X, that must be E. And this is the one we may get concerned about, but we did rearrange this earlier. Oh, that wasn't such a great straight line. If we rearrange it so that y is on its own, that really is an important step when figuring out what one of these graphs look like. And we can still see in the rearrangement process, squared didn't magically appear. It did happen to have a negative, but that just means it's going down. It's still straight. Wow, the question with the many answers. Sound is very low.
Yeah, let's just do a
Tell
little
you
bit of
what,
little bit
I'm
of
gonna hold the microphone like a really cool,
okay.
trendy person on TikTok. I'm just gonna hold it right next to my mouth. That surely will help.
Okay. Yeah, just a
I
little
love
bit of
that name though.
troubleshooting. Um, let's just check quickly. Is the sound okay? Hopefully, if you move the microphone, it's a little bit better.
Yeah,
Hi, Louis. Hi, Jenny.
Jenny with her friends. Have we got some new people here tonight?
Yeah, I think so.
Hello, everybody. Next one. Which two graphs pass through the point 3, 2? Here we go. So the method that I used earlier for coordinates is going to come back here as the most powerful method of doing this last one. 3, 2 is generally, it's not a nice point. It's not a special point like 0, 0. So the only thing we could do is say that if we have a straight line and some coordinates, and that straight line is y equals 2x, for example, every single coordinate on that line has to follow the rule that y is equal to 2 times the x coordinate. That's like it's a thing. And so if we put these values in, they have to follow the rule that is the equation. And if the following makes sense once you've substituted, then it's on the line. Y equals 2x, for example, if I put in 2 for the x, then the y must be 4. I put in 3, then the y value must be 6. There's no other way. However, if I put in something like, what would that be? Maybe 1, and then what came out here was 1.5, well, that's definitely not going to satisfy this equation. It will come out with an absurdity. For example, it'd have 2 times 1 equals 1.5, and 1.5 is not equal to 2, and therefore the point 1, 1.5 cannot be on the line. So if that's given you enough, what letters are question 4? See if you can beat me and you can put it in the chat. And Maths Explained can double check. All right, so let me go through and check. If x is 3, put it down here so I don't mess myself up, and y equals 2, is A going to work? Well, 2 times 6, no, A does not work. What about y equals 5? Well, if y equals 5, you get 2 equals 5. That's a load of rubbish. Same with C. You get 3 equals -1. What about D? We've got x is 3, so that'd be 9 equals 2. Well, that's rubbish. I'm hoping one of them works. It would be more fun. X is 3, take away 1 equals 2. Yes! Anyone said E before I got there? I don't know. You can see how that works, right? So we've got 2 equals 3 take away 1. So 2 equals 2. And in maths, if an equation works like that, we say it's satisfied. Satisfied equations. The last one, we've
Like
got
me after
3.
Christmas dinner. Very satisfied.
Say again?
Like me after Christmas dinner.
Holiday dinner, yeah.
You just
Oh,
sit there with your huge belly just rubbing it like, ah, yes. Very satisfied.
I was in Scotland over Christmas holiday, up a mountain, and also had a nice little cabin-like house with a fireplace, and I made a roast dinner, and I've got to say, it turned out to be the best roast dinner I've ever made. It was delicious.
Roast dinner in
Oh,
Scotland. Maybe
it's
some
one of the
rain, maybe
best.
some fog there. Or snow even.
Right. Oh, it was all sorts. We had snow, rain,
And a
fog, all sorts. And
hot
we'd
roast
always
dinner.
bring out our tea, tea formula, bringing the tea, got to on top of the mountains because you get these thermos flasks and
Yeah.
they'll keep your water hot. And it's just the best thing to have a hot drink.
Mm,
Or when you're cold, it's amazing.
mm.
It's probably an obvious thing to say, but you don't appreciate things as much until you're on the top of a mountain. Like after you've been on a long hike, apples are just the most divine thing. It could be ordinary on a day-to-day basis, and you may reach for a chocolate bar instead, but they taste so much better when you're starving.
Hmm.
Anyway, x plus y is 8. So if we've got x and y, they're 3 and 2. That's not quite going to make it to 8. So E is the only answer. Hamna Ali, well done. We've got
Nice.
one correct answer in the chat there. Okay, we're done these questions. That's a fun little warmer upper. And I feel
Hmm.
like these are the skills that you need if you're in an exam with an unknown like equation or graph and you're just poking around, substituting in, knowing how to navigate those graphs.
Yeah. And I like that we gave two methods there of kind of getting to those solutions.
That was cool.
Alright, next one. The graph shown below has the equation y equals a plus bx squared. What are the coordinates of the y-intercept? So if you've been doing some exam revision, you might see that this is not exactly an exam question. An exam question might say something like the graph passes through certain points, but here we're just asking you to look at the graph and find the points from the graph. So the first one is pretty straightforward as long as you understand what the y-intercept is. Very good, A. Nice. As long as you understand that the y-intercept is where the graph passes through the y-axis, you can read straight off that it's 0, 4. As A said in the chat. Nice. So what are the coordinates of the x-intercepts? Again, pretty straightforward if you understand what that means. Is where the graph passes through the x-axis, which is down here. Unlabeled axes. Not very nice graph, but there you go. So here we need to read them off, and they are 0. Whoops, already made a mistake. Don't do that. Negative 1, 0, and 1, 0. Okay,
Nice. Preet got there as well.
nice.
And
And
Jenny.
then the last one is where a little bit of challenge comes in. We need the equation of this line. So that involves using the points we've found so far and seeing if we can find these coefficients b and a. Well, hopefully if you know the quadratic is in this form. Well, okay, we're getting a little bit ahead of ourselves. Let's firstly say that we're going to use some of these points to find a and b. Well, let's start there. We could set up a set of simultaneous equations and plug those into this equation. So we're firstly starting with, and I'm going to write it like okay, we can't. Let's keep it the same. Usually I would write this as ax squared plus b, but we'll stick with how they've written it, just so it doesn't get confusing. And I'm going to plug in, well, actually, if x is 0, that gives us a, doesn't it? So if x equals 0, what do we get in this equation? We get y equals a plus b times x squared, or 0 squared. 0 squared is just 0, so this is going to be y equals a. And I've also need to plug in the 4 for y. So if x equals 0, we know y equals 4 from the y-intercept. So we're going to get 4 equals a plus b times 0 squared. That means a equals 0, a equals 4.
Problem solving.
So now we have a, so we can say, therefore, y equals 4 plus bx squared. And then we can use one of these points to find x. B. So let's use 1, 0. So let's say using 1, 0, we can say 0 equals 4 plus b times 1 squared. 1 squared is just 1. Feel like I made a mistake, but well, we've plugged in 1, 0, y is 0, x is 1. Well, it shouldn't be a mistake. That means b must be negative 4, right? 4 take 4 is 0, so b is negative 4. So now we have a and b. Then we have the equation of the quadratic. Y equals 4 plus, negative 4x squared. Let me rewrite that. 4 take 4x squared.
That makes sense. I think that's right. A is
Okay.
4 and B is negative 4.
Cool, and Jenny is reassuring me. Okay, so
It's interesting, that question, where it's not a typical one, but you never really get asked to find equation of a quadratic from coordinates, but it uses some good skills, right?
yeah, it's also interesting if you imagine that the quadratic was in the form ax squared plus bx plus c. That adds that adds an extra level of complexity. So here, notice we don't have this middle term in this quadratic. But it's interesting to think, if we did, what extra steps might we have to take here to find that equation? Which maybe we could tackle a bit later on. We're not going to right now, but
at least when x is 0, there's nothing else different. That's going to stay the same.
Yeah, but we can leave that as an exercise, something you can try also. Okay, on to the next one.
I like that. Do you know what this question reminds me of? It reminds me that I did a couple of unique ones on my Instagram where there was this random quadratic curve, just part of it, and some sort of geometry going off of that. That's what this one looks like. How do we... Oh no, that's not that. How do we move or make that picture larger? I don't think we can we?
Yeah, I don't think so.
It's all changed now.
Yeah.
I'm just going to have to do some form of estimation at least. All right, so the curve y equals ax plus bx squared, this is slightly different here. We had the constant last time, and now we don't have the constant, but we have the x. It's partly shown. Use the graph to find the values of a and b, and hence write down the equation of the curve. Well, without going into too much detail here, I would probably pick the nicest point possible, which is 0, 0. And whether I feel I'm right or not to begin with, I don't know. We have to see where this journey takes us. But with a little observation, we can see this is going to yield nothing. It's going to tell us something we already know, that 0 is equal to 0. So unfortunately, this one is not going to yield anything. So we're going to have to pick a different point. And in GCSE, maybe the question holds your hand a little bit, and it will say, oh, use this point. We're going to use our own observation here. I'm just looking at my whole integers across the x-axis here, down the bottom, and thinking which ones come to a nice point. And I'm thinking this one here. So I'm going with 1, 3. I can work with that for now, but I know where I'm going for one simple fact. There are 2 unknowns, And so I'm going to need 2 points. 0, 0 was rubbish. So I'm just going to have a look at what's going on with 2. 2 is a bit fuzzy. Or is it? Would it work? We can't do 3. 2 has to be, I think it's there actually. So 3 doesn't do anything. We're going to have to go with that one. So I'll write that down maybe here because I've got probably some work to do. 2 is in line with 8. So we've got 2 coordinates. These are
You're
like
you're
2
writing,
facts.
sorry, you're writing white on white. Just sorry. The coordinates you wrote down are in white.
Are they? They're black on my screen.
Oh, okay. Weird.
I noticed on the actual live stream that there's a large black region outside of
Yeah,
the question.
okay, hang on. Just a sec. Whoa, okay. There we go.
Is that better? Yeah, there you go. I don't know if that was it's going to
I had
affect
like
what
a night
people were seeing.
I had the night mode on, so it was a black screen. Sorry.
Oh, I should have been checking. Do you think people saw what we were doing earlier?
Yeah, yeah, they saw that.
Oh, okay, good. All right. Yeah, so we've got our 2 facts. We can put them in here. So we've got 3 equals, and we've got 1 for x. So we've got a plus b, which is nice. This is like a simultaneous equation. I generally like to encourage the use of calculators. I've got some TikTok videos, and maybe I've got some on, yeah, I think I put some on YouTube as well for the Casio FX991EX calculator. It does solve simultaneous equations. Um, Not that I would expect the GCSE to just give you a question that was so easy that you could plug it in a calculator like that, but you can use it in the GCSE, although some people might call it cheating. And you can solve simultaneous equations fairly quickly that way, if you want to double check your work at least. All right, we could put in our second fact now. So a is 2 this time. So x is 2. So we have 2a. X is 2 again, so we've got 4b. And this is pretty cool. We've got like a simultaneous equations now. We can multiply this by 2. We could do a whole elimination thing. So we'll probably put that underneath. It's a bit odd because we usually have the letters on the left-hand side. But it doesn't matter which way around it goes. We're going to eliminate with a subtraction. You notice I put the 6 on the bottom. That will hopefully be better for me because I'll have positive numbers, but we'll see. 2b or not 2b. We would just want b, don't we? So b equals 1. Lovely. And we know from our first equation that they must add up to 3. And so we know that a equals 2. And finally, we want to put those values into the equation because it looks better. A is 2 and b is 1, so x squared. And that's the equation of that line. Beautiful.
Nice. Hello, HA. Welcome. Yeah, it's interesting to look at these questions of finding equations from graphs. I feel like it's got a lot of real world connections. Like, there's a lot of times we see graphs and we want to model, or we see something in real life that we can graph and we want to model that with an equation. And being able to do this is, I think, an important skill.
I think so. That's totally true. You may have data and you want to draw its graph. I mean, yeah, you can turn to computers, but I'm going to counter what you said though, because in the real world, how often do you see data that's that straight?
No, yeah, you don't at all. And that's another
No.
skill of kind of approximating data with a formula, and it's
Yeah.
never going to be exact. But well, understanding why we do that is another interesting point. But by the way, do you mind if I switch the screen back to night mode? So maybe if you use like a different color instead of black.
I can do that, yeah, but the pictures are still going to be, they'll have a section where there's white.
Yeah, yeah.
So I'll just use like blue.
Okay. Alrighty, so
Well, wait, what color are you using? I want a color that
blue.
works on
Yeah.
white and black. So I wouldn't say yellow. Like orange works and purple maybe.
Yep.
I don't know how to change color anymore. Oh, that done it. I got it.
Okay, this one. The graph of y equals aq to the power of x is partly shown below, where a and q are positive constants. So this is an exponential graph. Find the values of a and q and hence write down the equation of the curve. So, well, we can use a similar process, even though this equation looks maybe unfamiliar. It's not a quadratic like the last two. Let's see if we can still do it using a similar approach. So this would be just equations of graphs, I guess, would be the topic. What would you?
Yeah. The topic is it's graphs, various graphs.
Mm.
It's
Uh,
understanding how to plot them, how to work with them, problem solving, and yeah, it's just going to develop those skills so you're comfortable with a topic that most GCSE students find ridiculously abstract and difficult.
mm.
And you will have to come to terms with it at A level. I would say a decent amount of the skills here are useful for exploring the more complex graphs at A level.
Yeah. So what we were doing before was finding points in the graph. So let's start with that. Let's say we have this point at 110. Again, I want to reiterate. Usually, if you're given, like, I don't want to always refer to exam questions. That's not the most important thing we ever have to practice. But if you are thinking about exam revision, you are generally given points. You're not given a graph, you're given points on the graph. But anyway, we're reading off the graph here, and we've got a point at 110. So let's see if that's enough. Let's plug that into the equation. So well, actually we have two unknowns. And as we previously said, with two unknowns, generally you need two equations. So let's see what we get if we plug in 110. So we would get, well, this is our equation, y equals aq to the x. Let's plug in 10 for y. So let's say using the point 110, we're going to get 10 for y equal to a q to the power of 1, which is just q. So here we get a times q is equal to 10. Or in other words, q is equal to a divided by 10. That's another way we could rearrange it. Maybe that would be useful. Okay, let's look at another point. Here is 220. 220. We could also probably use 0.5. In
I
fact,
think that would be, I feel like 0.5 will eliminate something for us.
so maybe if we use 0.5, that would be even more useful. So let's say using 0.5. We have 0 for x. So y equals 5. So plug in 5 for y in this equation. 5 equals a times q to the 0, because x is 0.
Woohoo.
Excuse me. What is q to the power of 0? What is anything to the power of 0? That is just 1, so that means we get a is equal to 5. That's great. So we now know what a is, and if we use this point we already used at using the point 110, we found q is equal to a over 10. Therefore, q is equal to 5 over 10, which is 1/2. And there we have it. We have our exponential equation. So final answer there, we get y is equal to 5 times 1/2 to the power of x. Okay. So even though you might see an unfamiliar equation, and sometimes they do this in exams. Again, I'm referring to exams like they're the most important thing in the world. I don't want to give that impression, but they are quite important for a lot of people. In exams, you might be given unfamiliar equations, but they'll be in the context of a question that you have the ability to answer. So here, well, we do learn about exponentials in GCSEs, but they might give you something that looks unfamiliar and you can use a process that you do understand to still get to the answer. So having that confidence is important in unfamiliar contexts. Okay, on to the next one.
There's just one thing. I think that Q might not be a half.
Did I make a mistake?
I'm just gonna put that out there. Yeah, I think if we use 110, because I was thinking I'm gonna double check the value of a half to see if it works.
Oh,
for
it's
another
10 over 8.
coordinate.
Oh, sorry. I'm testing your 10 divided by A.
Like, you think that's a teacher meme, right? Where you're like testing someone when you make a mistake, but it's actually like a really good teaching method. And even if you don't do it on purpose, it should be celebrated
I
because
always do it on
like spotting
purpose.
mistakes.
Yep. Okay. Thank you for. See, this is a benefit of having two people live streaming. You get to catch the mistakes. Hello, Rusty.
We've got a question.
The
What topic is
topic
this?
is equations of graphs, I think.
Yeah, all the skills that you would need, mainly knowing what a coordinate is, that it satisfies the equation that it lies upon, and then using key points on graphs. So it really develops your understanding of graphs. And yeah, this is a type of exponential graph. It's very, very common in STEM because it models things that grow exponentially, like populations of rabbits and stuff.
Okay. Are you tackling the next one?
Am I doing this one? Oh, this was really basic. This is a poll.
I'll be right back. I just need to grab a glass of water.
Yeah. This is going to go out to the chat, okay? Because this graph, let's read it. The graph below shows the parabola y equals x squared minus 5x plus 3. Find an approximate solution to the equation. So we want the solution to the equation. Where would you find the solutions? And it might be a hint that it's an approximation. I'm looking for estimations, answers in the chat. As we wait for Maths Explained to get a glass of water, we definitely have time to wait for answers to flood in. Where do you find the solutions to the quadratics? There's another clue in the question, isn't it? Because it says solutions.
So what are we asking for? What does that mean? What are the solutions?
I was looking for the solutions, just literally.
Okay.
You've got to understand what a solution is, but I'm looking for clues in the question, right? There's multiple. So we're looking to see what we're after. And I think we've got some good numbers coming in. I haven't checked them all, though. What we got around here, we've got in the middle of each of these, if we're careful, we've got a 5. And then halfway between that again, we've got 4.5. And there's always tolerances. If I went between 4 and 4.5, I would have 4.25. Now, considering that this is probably beyond the halfway point, I would be accepting any answers that were more than 4.25, I would say. Oh, it's for values of x, actually, isn't it? Yeah, so for one of them, an x is going to... Wait, have I got this the wrong way?
Yeah, that's right. Greater than 4.25 and less than 4.5, I would say.
No, but that's not the inequalities are the wrong way around. So x is more than 4.25 and less than 4.5, and I think we'll accept answers in that region.
Okay, so we had 4.25 from Jenny. Nice. What about let's give people just a little bit longer for the second one, for the first one, sorry.
Yeah, I'm just going to write that ready for later. So we're looking at the next one, which is the left-hand.
We had 0.75.
0.75. That's actually really, I think that's perfectly good.
Anybody else?
Jenny with her friends.
Preet says 0.75.
I think that's a good call because what we've got going on the left here is it passes through about there.
HA
So
says, yeah, seems about right.
I mean, if I'm going to be absolutely honest, I think it probably passes very near the middle, but if anything, slightly to the left. So what would be there? I mean, if I'm going to isolate it like I did here between 0.2, like a range of 0.25, I would probably say it's most definitely above 0.5 and less than 0.75. And I might just allow the acceptance of that because it's so close to 0.75.
That would,
I'm gonna give that. Do you feel that's fair?
yeah, I would even, yeah, maybe go up to 0.8, but yeah, around that mark.
All
Yep.
right. Next question. We have to upload some, don't we? A short intermission.
Yeah. Oh, so yeah, so just testing the idea that the solutions means where the quadratic cuts the x-axis.
Yes, but what else do they call this? I've just had a thought. What else do they call those points
Oh,
where it
does
crosses?
anybody know another name for those points?
We could play a game of hangman. And we're going for the plural. Okay.
Oh, nice.
Whoa.
Wow.
All right then.
Preet, relatable, Aaron, ten,
Totally ruined
10 points to
the game.
Gryffindor, or whatever house you belong to.
Do you know, I think it's always pretty to look at the roots like this, right? Because you've got a tree. And I think this is why they called it roots, because a tree has roots at those point. That's the point where it goes under the ground, right? So I feel like those are critical
Hmm.
visualization.
I remember
Right.
reading why they're called roots, but yeah,
I bet it's nothing to do with trees, yeah.
well, yeah, probably not, but yeah, something I can't remember now. Okay, so we'll go on to our first irrational questions. Hello, Mohammed. So we delete the picture and the writing, and then we get our next question.
No sense in doing them all at once. Just do the questions one at a time now, I suppose.
Okay, so we're changing topics a little bit here, changing direction slightly. We're moving on to irrational numbers. Have a bit of a starter question here. Find two distinct irrational numbers x and y such that, or so that, x times y equals 10. No worries, HA. Have a good one. And then question 2, it says find two distinct irrational numbers a and b so that a times b equals 0.5.
Whose question is this? I feel like it's yours because I kind of did that one. I led
Yeah, sure.
the hunt for the previous one.
Minimax. Not sure what Hamna is referring to. Minimax. Oh, roots? Well, not exact. Roots are not exactly min and max points. Can you go over vectors where you have to solve the ratio of a line? We did a little bit of that. So if you watched the live stream from last week, we did do a vectors question.
We've done a big load of vectors, didn't we? I think we did quite a few on vectors. We did a whole set of vector
not
questions.
last week, but one of the live streams we did.
Yeah, one of
It will
them.
be titled in the thumbnail. It will say vectors. If you want to revise vectors, also I have quite a number of videos on vectors. We're not going to do vectors today, sorry. But maybe we can take some questions. If you have a specific question, we can take some at the end. But we don't have any ready to go through. Okay. Firstly, what are irrational numbers? What can anyone tell me an example of an irrational number? Well, I won't really wait for any answers, but well, actually, an irrational number is generally defined as a number that cannot be written as a fraction. Pi is an example of an irrational number. So another way to describe an irrational number is it has, infinite decimal points. So if you talk about pi, 3.147, nope, I'm forgetting it. 3.14159 3.14159 I think, if I got that correct. But yeah,
You're a better man than me for knowing.
these decimal points go on forever.
Although I did see a really good video recently on a book about pi, and it was pi to 1,000,000 decimal places. That was a good read.
Pi to 1,000,000 decimal places. Okay.
Yeah, it was so funny. And
Yeah.
then the second book that they were reading was the square root of 4 to 1,000,000 decimal places.
Right. Square root of 4 to 1,000,000 decimal places. That would be an interesting read.
It was
But
2.0 all the way. And it was like, oh, I can't wait to find out how it ends. So funny.
Can pi be expressed as 22 over 7? Yeah. Good one. Good one, Muhammad. So, what was I saying? Yeah, that's one way to describe irrational numbers. Basically, they can't be written as a fraction. Oh, by the way, we had a competition at a school I used to work at where they had, how many digits of pi can you recite? And one of the students could say it to 1,000 decimal places, which was
really?
and I saw it. I saw him do it. It was kind of crazy. So another type of irrational number is surds. So square root of 2 is another type of irrational number that cannot be written as a fraction. It will have decimal places that go on forever. So square root of 2 is 1 point something 4. Is it? I don't remember square root of 2. Let me put it into a calculator.
Square root of 2 is 1.41, I think.
1.414.
Yeah.
Approximately.
But the point is, with an irrational number, it cannot be written as a fraction.
Yeah,
So
I said
I'm
that
going
a
to
couple of
just
times.
point out, Mohammed, in chat, you say, can't pi be expressed as 22 over 7? We have to be careful there and say it's approximated by 22 over 7.
Yeah, approximated to 22 over 7. So I think we're going to focus on surds here to answer these questions. And can you think of a method to multiply two surds such that you get 10? So one rule of surds that you'll find useful for this question is that if you have the square root of a times the square root of b, this is equal to the square root of a times b. So if we can think of two numbers that multiply such that we get 10, the square root of what is 10? The square root of 100 is equal to 10. So if we get two numbers, a and b, that multiply to 100, then we will get 10 here, and they will be irrational. So basically that's what we're trying to do to answer this question. We want the square root of something multiplied by the square root of something else equal to the square root of 100. And Jenny already is giving me 50, so the other one then stands to reason. We would have square root of 2 times the square root of 50. That would give us the square root of 100, which is equal to 10. And these are both irrational numbers. Another one, that would work as well. The square root of 4 times the square root of 25, although here actually we need to double check something. Square roots are not always irrational, are they? Sometimes if we have a square number, it's not irrational because the square root of 4 is equal to 2 and the square root of 25 is equal to 5. So not all square roots are irrational. Only the surds are irrational. These are numbers that you can't take the square root of, basically. So this one wouldn't actually work because these are not irrational. Not irrational. Okay, good try though. Okay, so we get one answer there, square root of 2 times the square root of 50, which would satisfy that question. I should say x equals and y equals
50.
50, yep. That's so great. Having someone to pick up on my silly little mistakes that I always make. Okay, next one. Find two distinct irrational numbers a and b so that a times b equals 0.5. Well, now we have a method that we use. So basically we're saying, well, we want the square root of something times the square root of something else to be equal to the square root of what gives us 0.5. The square root of what equals 0.5. That's a little bit trickier. So I'll give you a moment to think about it. For whole numbers, it's a bit simpler, right? Square root of 100 is 10, the square root of 16 is 4, the square root of 4 is 2. For fractions, you can use the same approach. Muhammad says a quarter, excellent. The square root of a quarter is a half, so the square, you basically take the square root of both numbers in that fraction. So we want two numbers here that multiply to give the square root of a quarter. Thank you, Tasnim. Glad you find them useful. Okay, Jenny already has one solution. She says the square root of 2 and the square root of a 16th. Let's see if that works. 2 and a 16th. So what would this be? Well, this would just be the square root of 2. This would simplify to well, actually, this would be a rational number, right? This is rational. Sorry, I initially when I looked at it, I thought you would be correct, but I just noticed that's rational. So that doesn't quite qualify.
Yeah, we've got to be careful of those rational numbers, right?
Yeah. So one that I thought about was, I'm forgetting now.
I think you said one of them was like, did you use what we're looking for?
Oh yeah, I used. So if we say the square root of a half, and then a square root of a fifth, and 5 over 4, that could work.
That would be 5 over 20, which is, yeah, that works, yeah.
So you can use the fractions in that way if you see them simplifying. You can also think of this as decimals. If you think of two decimals that multiply to 0.25, if you prefer to think in decimals, you could do something like 0.2 times 1.25. If you prefer to think of it that way, you don't have to use fractions, but that's the same as these fractions.
But it's also, if you did it with decimals, you run the risk of not really knowing if it's irrational or not. It's harder to see if you can't see that the whole numbers are going to be root 5.
So what about root 2 times the square root of 1 over 8? That should work. That looks, they're both irrational.
Yeah.
And then 2 times an eighth is a quarter. So there's another solution. Nice one. So let's use that one because I like it more. So x is equal to root 2. Sorry, a, not x. I'm writing x and y. Oh, the first one was x and y. That's why I got confused. The second one is a and b. So a is equal to root 2 and b is equal to square root of 1 over 8. Very nice. Okay. So we have more irrational questions. We have to just erase the other pages first.
More questions on irrational numbers, though. I mean, if we're going to give someone an irrational question, that's not really fair.
It's all pretty irrational. Okay.
Did you see my joke that I put in the chat? That's quite funny, I thought.
Why are irrational numbers not allowed in the Olympics? Because they can't be measured in a finite amount of time. Ha 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 ha. Are you a dad?
I should be. I'm not a dad yet.
Right. Can you
What
do a
questions on the
live
table?
stream
Oh, here we go.
for...
A voting question again. I get the voting ones.
Sorry, Can you do a live stream for GCSE additional maths? So additional maths, I assume you mean further maths? Like the,
Yeah,
who does
it's
that? AQA.
preparation, isn't it, for A level? They do in between.
Oh,
They learn
right,
the
additional
basics of
maths. Okay.
differentiation.
I have an AS level question lined up, which would do maybe at the end, which I guess qualifies as additional maths. So if you want to stick around for that, we'll do that towards the end, if people are interested. All right. Sorry for interrupting.
No problem. I'm just typing in chat as well. And then away we go. There. Okay, so put a tick in the box underneath the irrational number. So we've already talked about irrational numbers. So I reckon we've learned a lot about what an irrational number is here. So I reckon we can do this.
Oh, this should have been this should have been before the first question, maybe.
Very possibly. So if we call this A, B, C, D, etc., we can go through one at a time and we can vote. So let's say we'll start with A, and we'll make it nice and easy in the chat. Do it one at a time. Is A an irrational number? We're looking for a yes or a no. No, indeed. I might just like the first person that does the answer. I'm going to go with that. So well done. Root 16 is something that can be written nice. It's a whole number, and it's something that terminates. So it can be written as a fraction too. It's all good. What about B? No, indeed. They think that B is not irrational. That's interesting. I can say the square root of 9 is 3. I can say the square root of 4 is 2, because these are very special numbers. As we discussed earlier, they are squared numbers. So like 1, it'd be good to remember these. 9, 16, 25, 36, etc. All of these will turn out, if you're square rooting them, to be nice whole numbers. Unfortunately, as nice as 8 looks, it's not very nice. You can change and simplify 8 to be the square root of 4 multiply the square root of 2. And the 4 is going to become 2, but the root 2 is going nowhere. So unfortunately, this is irrational. Interestingly, if you have an irrational number here and you multiply it by a whole integer here, it's still going to be irrational. So unfortunately, this one isn't. This becomes 2 root 2, and there's nothing we can do about it. So that might give us a little hint here. What about C? If you think about what 2 is, you've got 1.41 dot 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 dot. It goes on forever. It's irrational. And then we're going to add 1 to it. It's just going to become 2.41 irrational. So adding and subtracting numbers, like, it's not going to do anything to the irrational part of this. It's just not, we're up to here, by the way. It's just not going to be, it's still going to be irrational. So in fact, this is the form that we keep it in, because there's no way to break this down any further.
So I'll just so it's clear, so we're putting a tick, right?
I think I was
Under
just
the
putting a
irrational.
cross based on where we were up to, but
Oh,
we
okay.
could do ticks. Why don't you
Just so
do the
it's
ticks
clear.
in blue? That would be easier to see then.
Underneath the irrational numbers. So these were irrational. Okay, so
Yeah, they were irrational, and the first one wasn't. So now we're on D. It's probably just I'll change to a circle because it might be confusing. So D, what about this? Is D? We're saying yes, it is irrational. We can work it through. So we're trying to look for the biggest factor that's a square number, right? So 32, we've got root 16 times root 2, and then root 2 on the bottom. Oh, lovely. Those two, root 2's cancel, and then we have root 16, and root 16 is 4. Oh, there's a shocker. So
oh,
in fact, that is rational.
tricky one.
It didn't look like it, but if we've got the skills of simplifying surds, sometimes, it can surprise you. All right, what about E? We're up to E now. Vote on E. I can't tell whether the previous no is equal to.
So that was the previous one. So we're up to E. Any
So
new
we should say,
answers?
like, if you give an answer, just say E equals no or
Oh,
something
that's a
like
good
that.
idea. E.
You could
E
put it like
is
you need a bit of time to work it through, I guess. But you can simplify the surds and see if they simplify to something nice. I can see that this one does simplify, but is it nice? Right, we've definitely got a yes here for the newest question. And maybe that's all we're gonna get. It does, maybe it requires to write it down and stuff.
yeah. I
So
think people
it does
maybe are writing it down and trying to work it out.
exactly. So I might work towards it slowly. So if I've got root 100 on the top, thinking about that as like a number that could be a factor or something, and it's fair enough. It could be changed to 10 straight away, but it might not be the best thing to change it to, considering that the bottom is root 50, if that helps. I might instead want to change it to a root 50 multiplied by a root 2. And that allows me to cancel this down a little bit better. So there you go. This is irrational. Nothing we can do about that.
So E is irrational. Yep.
Yes.
Welcome back, HJ.
Okay. How do we even tackle decimals? We talked about this earlier. The fact that if it's a fraction, it's much easier to see the irrationality of a thing. So how do we even begin to look at this one? 0.9. We've got a strategy. The rules of surds are not really built to work with decimals. We do want to some sort of conversion. So as I did mention in one of my videos, mathematics is often about rewriting something in a different form in order to get insight or to better work with it. Things like the binomial expansion, for example, or Maclaurin series. Multiplied by 10. That would be very interesting. If I multiply it by 10, for example, how would I absorb that? Well, I could say 10 was the square root of 100, and then that could go in for sure, and then I would have the square root of 90. It's harder to say multiply by 10, or maybe we could just write the 0.9 as a fraction. Like maybe we could say 9 over 10 is probably the easiest way to look at this that's been square rooted. And square root surds, you can square root the top separately to the bottom. The top, yes, looks good. The bottom, not so much. Root 10 is one of those surds that we think, there must be a nice factor in there, but it's not. So unfortunately, that was a yeah. Well, actually, what do you find? Is it fortunate that it's irrational? In the context of this question, we're trying to find the irrational numbers. We get a nice big tick for that. But in real life, nobody really enjoys working with irrational numbers because they're undefined. So in the same manner, we might want to use the method that was mentioned by HA earlier for this one. I think this one would work really well for this, perhaps, because instead of having zero point 0.9 under there,
Tasnim says, can you switch the decimal into a fraction?
oh yeah, for sure. We could do that method. What would that be that's a skill in itself. What is 0.09 as a fraction? Well, here we've got tenths and here we've got 100ths. That might be a clue. I'll go through the other method first and then we'll go back to the fraction. So if we multiply this thing by 10, it's 0.09 and 0.09, which underneath is rather elegantly turned out to be square root of 9. And we know the square root of 9 is 3. So unfortunately, that's not irrational. But we do want to tie up that loose end, right? So we're going to have a look at the turning it into a fraction first, because fractions are really how we figure out what's going on with the thirds. If you're looking up here, we've got a 9 in the 100th column, so we can call that 9 over 100. Over time, that seems like a silly thing to formalize, but if you didn't know it, that's a crutch, something to lean on in the exam. Now, this is being square rooted. We can square root the top, and we can square root the bottom. And so we end up with something nice. Just to say that this method here, multiplying it by 10, I don't know why we're going down that avenue. I just had this thought. It's interesting to follow the ideas, but this is a totally different answer, by the way. I just want to point that out. I follow what gets suggested, but we should probably point out that you can't just multiply a question by 10 because it changes the actual answer, right? The answer will be 10 times bigger. So at the end, we've got to go ahead and if we want to know the true answer, we're going to have to divide by 10 again. This will become obvious when we do it the proper way up here. So we've got 9 over 100, and that's going to be square root of 9 over square root of 100. And then we get our 3 over 10 as we saw down the bottom. So yeah, this is possible, but be careful at the end. Caveat came at the last minute. So for the final one, G, it's not.
It is rational. Interesting.
It's rational. It's one of those good fellas.
It's interesting when they're written as fractions compared to decimals. It's like, if you see that written as square root of 9 over 100, you think, oh, that's, well, depending how used to it, you think, yeah, immediately that's rational. But if it's written as 0.09, the square root of 0.09, it takes a minute to think, oh, wait, is that irrational? Because it looks like on first glance, oh, surely it's irrational. There's all this decimals and things. But yeah. Okay. Can it also be 3 root 0.1 since they both have the same value? 0.3. I don't think so, Mohammed. I'm not sure how you got to 3 root 0.1. So root, oh, yeah, it could be. Yes, root 1/10. Yeah, you're right. Square root of 0.1 is the same as the square root of 1 over 10.
Isn't that a thing that I've come to appreciate like more and more? We're just rewriting expressions in different ways, and it's like, wow, it suddenly reveals itself to be rather easy.
Root 0.09 is 0.3, not 3. Change.
I think what they're talking about down here, right?
Yeah. So I think you already referred to that.
So just to, who was saying that? Jenny with their friends. I talked up here. We had somebody. Was it HA? HA suggested, why don't we multiply it by 10? So I was working through what might happen if we multiply it by 10, and you could figure out something about it. But yeah, you have to divide by 10 again at the end. It's a lot like when you're in year 7, or it depends on which country you're in. So let's say you're 10 years old and you're told to do 0.3 times 0.07. And you're like, I can't do that. So they tell you to times it by 10 and times that by 100. So we get 3 times 7, which is 21. And because you made the problem 1,000 times bigger, we divide. So we've got 1, 2, 3. Yeah, we divide by 1,000 at the end, and then that's the true answer. And it's a bit like that. We scale the question. But I did come back to that.
Okay, next one. Let's clear the page. Let's clear this one off. Okey-doke. Was it this one?
What we got coming up next?
Oh yeah. Write an irrational number between 0.25 and 0.5. Okie doke. So this is a little bit of a jump from the previous question. So the previous questions we were kind of asking, well, do you understand what irrational numbers are? In this one we're saying, well, can you identify some irrational numbers as kind of signposts? So can you find like a lower limit and an upper limit? Or in other words, can you find what these decimals would be equal to as irrational numbers? So we're kind of going the other way. So what would well, they're not irrational, but I kind of misspoke there. But if we were to write this as a square root, what would it look like?
Did we say no calculators, by the way?
No calculators, yeah. So we're trying to do this without a calculator. Oh, Hamna, yes. The golden ratio is a very beautiful irrational number. I agree. What is it? It's 1 take...
1.61. Oh, sorry, go on.
Is it 1 take root 5 over 2, or is that...
Are we talking
something?
about phi?
Yeah.
I'm not sure about all the equivalent forms. It's about 1.61, isn't it? The same as a credit card or A4 paper.
In surd form? Can someone help me out? I don't exactly remember what it is in surd form. It's something like that. Anyway, so we want to write 0.25 as a square root. It's not an irrational number, but if we want to find an irrational number between these two decimals, then we want to write these as a square root, and then maybe we can identify an irrational number between them. So 0.25 is a quarter. I prefer to work in fractions. I just find that a little bit simpler. So if we wanted a square root equal to a quarter, we actually talked about this before. Well, this would be, think about what is the square root of something equal to 1? That would be 1. What is the square root of something equal to 4? The square root of 16 is equal to 4. Oh, so it's 1 plus root 5 over 2. I had the negative wrong. So 0.25 is the square root of 1 over 16. What about 0.5? We want a square root equal to a half. Well, using a similar process, that's 1 over 4. The square root of 1 over 4 is equal to a half. Okay, so can we identify a number between these two square roots that is irrational? Okay. So what basically we're asking, what is a fraction between 1/16 and 1/4? And then we're just going to put a square root symbol over it. So that's kind of just the question we're asking. What is a fraction between 1/16 and 1/4? 0.39, I can immediately tell you, won't qualify because you've written it with 2 decimal places, which means it's rational. So we're looking for an irrational number.
What a true story.
I love people participating.
So do I. That was good.
Good try. So the reason why I suggest doing it this way with fractions is because it makes it a little bit easier to identify a fraction between a 16th and a quarter. Well, that's another skill in itself. Identifying a fraction between two other fractions is kind of tricky, but let's firstly say the numerator will be 1. So what denominator could I use here? Jenny says 1 over 9. Yeah, we could use 1 over 9. The problem with using 1 over 9... well, can you tell me what the problem would be with using 1 over 9? I think I see...
You're asking me.
I think I see that you've seen these square numbers, and I would do the same thing. I'm looking for a pattern. I want to use another square number. But we want to avoid using square number because we're looking for an irrational number. So,
can we just talk about what 1 divided by 9 is for a second?
Sure. If you want.
Because, like, I made a comment in the chat, and I said that what we're looking for is something that doesn't terminate. And actually, 1 over 9 is one of those really strange decimals that doesn't terminate. So I just want to be clear that although it is 0.1 and it doesn't terminate, it goes on forever, this can be written as a fraction, right? This is a difficult thing. We were looking for an irrational number. So, we've got to be careful with that one.
Oh, yeah, that's a good point. Yeah, so recurring decimals, true, are not the same thing as decimals that go on as irrational numbers. You can describe them as decimals that go on infinitely, but they can be written as a fraction.
I think the GCSE uses the terminology non-terminating.
Non-terminating, yeah. So a couple of good answers here. 1 over 7 or 1 over 8 I think would both qualify. So we could use 1 over 7 or 1 over 8. And I think they're both quite good. So they're both going to be irrational. I'm going to use 1 over 8, but there's nothing wrong with 1 over 7 either. So I know that fraction must be between a 16th and a quarter, because the numerators are the same and the denominator is between 16 and 4. Okay? And this is going to be irrational because the square root of 8 is irrational. The square root of 8 we talked about on the previous question is 2 root 2, which is irrational. So the square root of 8 will give you an irrational number between 0.25 and 0.5. So
if you want to know that the number that we just found, it's 0.3535533,906. Honestly, there's no padding. It goes on forever.
So two answers there. Square root of 8, the square root of 1 over 8, the square root of 1 over 7. Square root of 1 over 11. Yep, exactly. I think we're starting to get the idea. Basically,
we're looking... That's a really logical method. Well done.
Yeah. 1 over 8 is 0.125, but the square root of 1 over 8 will be irrational. Well spotted. 16 times 4. And then this, so the square root of 64 is indeed 8. Okay, we have a bit of, okay, Jenny agrees with me. Hopefully everyone else does. Yeah, that's an interesting point though. 1 over 8, well, these fractions are obviously rational, but we are taking the square root of it. We're taking the square root of that.
Yeah, that's the key.
That was the point. Okay, so final answers there. A couple of examples, but there were probably infinitely many answers to that question. But that was one. That was one process you could use.
I want to make that clear, like, because I was talking earlier about the terminating nature. I guess we got mixed up with what we were asking, but it's when you square root it, the surd should be non-terminating. That's what we're getting at. And then we talked about the distinction between non-terminating and irrational, because you can have some that don't terminate, but they're still rational. Anywho's.
Yeah, it's, I guess, a little bit hard to define in a way, but yeah. I like just the general definition. You can't write it as a fraction, basically. So you can't write it as a ratio. Okay,
That's used so often in proof.
two more questions. Okay, we're getting onto a little bit more geometric. Absolutely
And is it?
nothing geographic
Do
going on
we are
here.
we doing this one first? Yeah, let's do this one first.
Or what do you think?
I I think the other one.
Oh, okay, let's do the
I
other
feel
one.
like this will give it away a bit, and I would prefer the challenge first, and I think we can give this one a second after we do the other one. Mohammed, is this going to be in the GCSE? Nothing is guaranteed. I think, Mohammed, I think, and I could be wrong, but we have had a discussion that you are a tutor. Is that right? Did I get that right? Has a
No,
passion for maths. I believe you have some video. Anyway, no, it won't. It's not going to be. We cannot tell you. I would love it if some question we did was in the GCSE, but we're doing skills applied in different settings, and hopefully we're learning the skill on how to adapt to unknown situations, so that when we get into the exam, that unknown situation, we can handle it with confidence. We want to be in as many unknown situations and stay cool as possible so that we're ready.
yep. Tasnim says, Excel will put that question on. They're a nightmare. I like the optimism.
Is that because edXL have I don't know if you know this, but they've got a reputation of leaking questions and papers out. Like people are always leaking them out, selling them online early. So whole groups of people need to resit.
I think they had a couple of instances of that. I'm pretty sure they've like kind of locked it down so it won't happen again. But yeah, I'm not
Well, they
sure.
always try. In the last 6 years, they've had three that I know of anyway.
Hmm.
And to be honest, that's three too many. But hey.
So, do you want to get stuck into this one or?
Oh, is it me? I think it's your turn, isn't it?
Sure. Okay, this question says a plank of wood which is 1 meter wide fits tightly in a square room with side length of 8 meters as shown below. Calculate the exact length of the plank, leaving your answer in third form. Okay, wow, I have an answer already. I'm not sure how you came up with that so quickly because the method I'm going to use here is pretty long-winded. If someone has a way of doing this quickly, then I'm all ears. But I'm just going to use a logical approach that makes sense to me. And I'm going to take this one step at a time. So if I want the length of this plank of wood, the issue is, well, I can find the diagonal. I can find the diagonal of this square pretty simply. Okay, I can find the diagonal of this square with not too much trouble because I know about Pythagoras. And Pythagoras says if I want the diagonal, the hypotenuse of a right triangle, then I can use Pythagoras. Sorry, I'm just getting my inks sorted out here. If I want the hypotenuse of a right triangle, I know that a squared plus b squared equals c squared. So I can use that to find the hypotenuse, which is the c in this case. In other words, I get 8 squared plus 8 squared equals c squared. Which I'm just going to write as 2 times 8 squared. And then if I take the square root of both sides, I get c equals 8 root 2. So the diagonal across the diagonal of this square is 8 root 2. Okay, hopefully I didn't go through that too quickly. And another little shortcut, for any square with a whole side length, the diagonal will always be that side length times root 2, by the way. So if you have a square of side lengths 1 and 1, the diagonal is just root 2. If it's 2 and 2, the diagonal is 2 root 2, and so on. Okay, so I have the diagonal. The problem is these little lengths here. I need to find these little lengths in the corners to find the length of the plank of wood. So how do I find that little length? Well, the way I'm going to do this is to find the lengths of this triangle in the corner. Hopefully you can see what I'm drawing here. This right triangle in the corner, I'm going to try to find the side lengths of that. Now I know the hypotenuse is 1, so again I can use Pythagoras. So here, for this little triangle in the corner, hopefully you can see that I'm highlighting that. I'll redraw it over here actually. I know the hypotenuse is 1, and I know these side lengths will be the same. Because this is a rectangle stuck into a square, so these lengths here must be the same. I'll call those D. So I have D squared plus D squared equals 1 squared. Using Pythagoras again, the 2 legs squared and added equals the hypotenuse squared. Okay, so now I know D is equal to 1 over root 2. Let me take a few more steps to do that. So 2 lots of D squared equals 1. Dividing both sides by 2, I get D squared is equal to 1 over 2. So D is equal to 1 over square root of 2. Or you could also write this as root 2 over 2. These are actually the same. And I don't need to add a plus or minus because we're talking about lengths, so we're not going to have a negative length there. Okay, so we have the side length of this little right triangle of root 2 over 2. Now I want the length. That's kind of bad. Let me redraw that. Now I want that diagonal there that goes from the corner of the square to the edge of the plank. Let me use a ruler. This diagonal in here. So we still have some answers rolling in. That's good to see. I'm not going to check if you're correct. I'll just check at the end to see. So hold your horses if you're waiting for an answer. Or maybe T-Formula's already told you in the chat.
I've actually already checked. Jenny's got the correct answer.
Okay, awesome. Well, okay. All right, so we're looking for this length here. And because we know the hypotenuse, the total length of the hypotenuse is 1, we know this little length is going to be a half. Okay? So now I have the hypotenuse of another right triangle and another leg, and I'm looking for the other leg of that right triangle. Now we could take a little shortcut here and say, well, actually I know these two legs will be equal, but let's go ahead and make sure that's correct, again using Pythagoras. So we have the hypotenuse squared is equal to the 2 side lengths squared. That's a half squared plus this length. Let's call that A squared. So what are we going to get for A here? Let's square these. This is going to be 2 over 4. This is going to be a quarter, so we'll subtract that. So here I've subtracted a half squared from the left-hand side. What am I getting there?
Sorry, has you got a half, take away a quarter, that's a quarter. And we square root it, we get half.
Oh, right, yeah, it's a quarter. I was thinking it was a half. So 2 over 4 is the same as a half. Take a quarter, which is equal to a squared. A half take a quarter is a quarter, so we get a squared equal to a quarter. And then, therefore, a, the square root of a quarter is a half, so a is equal to a half. Okay, so that little length from the corner of the square to the edge of the plank, which I've drawn terribly there, but hopefully you get the idea. This little length we talked about at the very start, the big problem we were having, is equal to a half. The total length of the diagonal is 8 root 2, which we established at the start of the problem. So if we look at that total length of that diagonal, which is 8 root 2, we subtract this little length, which is a half, and this little length again up in the top left-hand corner, again, which is a half. We're going to do 8 root 2 take a half, which is 8 root 2 take 1.
Very nice.
Which is our final answer there. Let me just write that. So final answer, 8 root 2 take 1. And there's really no way of simplifying that any further. I think that's the neatest that we can write that, so we would leave it in that form.
I was going to think of a joke. After all of this work that we've done, it says, what is the exact length of that plank? And I saw you had a ruler out. I was thinking, okay, you're gonna literally measure this and cheat.
Yeah, easy.
But it's actually a fantastic question to ask. Could you measure that with a ruler? And it's something that the Egyptians, in fact, were fascinated by. If we have a 1 by 1 like this, the hypotenuse is a third. And they were fascinated by the fact that you couldn't actually measure it. Even if you had a ruler, it would never quite match up with one of the notches on the ruler. It's always a little bit off of each one. And it goes on forever, you see. And they were fascinated by this idea of something that was immeasurable. So you couldn't just measure this with a ruler. Mathematics is going to help you find the exact answer.
I just realized there's another way to do this. If you subtract that length there,
yeah, I was thinking
and
that
get this
because I've got a
length,
bit more time to think when I'm not actually doing it.
and then you get that hypotenuse.
I'm not sure I like it as much. I feel like what we'd end up with is, what was that little bit? Was it 2 root 2?
Yeah, 1 on root
Or was
2
it
or root 2 on 2, either way.
It was root 2 over 2, right? So you'd end up with that being the length of one of the legs, and then you'd have the same over there. And then that might be a little bit harder to do than the method here.
Yeah, a little bit messier maybe.
But that's Pythagoras twice in a row. You may be bored of that.
Okay, there you go. Hopefully you found that question interesting. And people got to the solution really quickly.
Yeah, go Jenny.
Was there a different method given?
Not particularly method-wise, but I know there was a solution fairly quick from Jenny, and Mohammed was talking about using Pythagoras twice, that's probably the way I would have seen it. But I've got to say, overall, I prefer the way you ended up doing it. I feel like that's the winner. That's going to get the chicken dinner.
Jenny, I don't fully understand what you mean when you say I joined 2 triangles and its diagonal is 1. So if you maybe describe your method a little bit more, and then I could say if you were correct or not.
I mean, you got the correct answer, but sometimes you accidentally get the correct answer. Do you know what I mean?
Yeah. Oh, she just asked, is my method correct? I just wasn't completely sure.
Yeah, no, I agree, because it's not enough information for me either. Join 2 triangles, which 2 triangles, and in which way? You definitely will get a square, but we're still looking for a hypotenuse. We join 2 triangles.
Okey-doke. Yeah, so 8 root 2 take 1, final answer for that one Um, we'll jump on to the next one. I am still waiting for your method if you want to put it in chat, and we can go through it. But for now, we'll proceed.
Here we go. Those two corner triangles joined and we get a square.
Those two. Okay, so let's jump back for a moment.
So they do join to get a square, and that means that the length of the plank would be pushed to the far corner.
Wait. Which two triangles?
You see the little triangle either side of the end of each plank?
So these two little ones.
If we move that triangle at the top left down to meet the bottom one, we'd have a square down there, and that would push the plank so that the top of the plank in the top left would be exactly on the vertex of the square. I think we're still in a very similar situation as to the other ones, but I think this is a way of seeing it.
So diagonal is 1. So we cut these triangles out and join them together.
Yeah, should we clear it a bit, and then I think it's something like this. So let's actually use the square function here. Something like that, which would then push the plank to be like here. It would start there and it would sort of end here now. See?
Oh, nice. That's so cool. That's awesome. I love it.
Yeah, and then look, you've got that line going straight up, and it's quite a nice triangle then.
So all you did was just shift the plank up. Oh, that's genius, Jenny.
Yeah,
I love it. See, people can see solutions sometimes to problems that just click. So I think that happens to many of us sometimes. We see a problem and it's like, oh, why don't you just do it this way? And I love when I can't see something and someone else points it out and it's like, wow, cool. Yeah, nice one.
Yeah, no, that's a great feeling.
Alrighty.
I think we'll leave this up to the chat, shall we? The squares are fairly supportive.
Well,
and use of the squares. It's very similar methods. See how they go.
Let's read the question. So, question says, part of a 5x5 square is shaded by a triangle as shown below. What percentage of the square is shaded? Will we get marks? You get points for your house. So, what house are you in? Gryffindor, Slytherin, Hogwarts, or Ravenclaw? You'll get house points.
You can get a smile from me. That's a good one.
So we're waiting for some solutions, and then
I don't know. I think we've got the idea here, and they're probably going to be working away. So why don't we work away slowly and see who wins?
Okie doke. And you're going to go through this one?
I can do it. Yeah, sure. So I'll work my way slowly as I do.
All right.
And there we go. I'm probably going to go for the three triangles. I don't know. What would be the method?
Well, let's not give anything away. If we're going
there's a couple of ways of doing it, and I think I'll probably do it the way I'm initially going to with surds to stay on topic, and then you can chime in if you see a different way. Yeah.
Did I say Hogwarts is a house? Whoops.
The Hogwarts house.
Maybe it is a house.
Wait, we've got to think. Is it Ravenclaw, Gryffindor?
I said Gryffindor, Slytherin, Ravenclaw, or Hufflepuff. Oh no, I said Hogwarts, not Hufflepuff. Oh my gosh, I'm so embarrassed.
Hogwarts, a history. Right, so we've got 1 by 1. Oh wait, I'm still in the line
I
mode. Let me
forgot
get into.
Hufflepuff. How
I'm
could
in a
I?
race here. I got to get going. Jenny's going to beat me. Right, we've got we've got each of these squares are one.
I think
So
I like
drawing
to
this
just
separately.
repeat, we are waiting for solutions to this question on the screen. So if you have got a solution to the question on the screen or you're working on it, we are waiting for your solution. So type it in the chat at any point when you get an answer to this problem.
You know what? I might just win if I'm not careful because I feel like I've just seen the whole solution pretty quick. So, oh, it's hard for Jenny can't see this one. Okay, cool. I'm just gonna slow down there then. I'm just gonna say that's where I'm gonna start. Why don't we slow it down and say Mass Explained or Joe? Where would you start? Just to start. Give a little
Well,
tease out.
because we're looking for areas, I would just look for some areas. That would be
Hmm.
that would
I
be
didn't go for
all that
that.
I'm gonna
I'm on
say.
my way. Yeah.
So it is a percentage. So remember to give your answer as a percentage if you do get to the answer. So we are waiting. There's no rush, so don't feel you have to rush at all. Take your time.
Absolutely.
Have a think. Oh, sorry. A says, okay.
Who's like A? We haven't had a chat from A. Hello there. We like when people get involved.
Yeah, we love it.
And look at that for an entrance. I do believe that's correct. Oh my goodness,
You
Lam
know, we
Fang.
shouldn't give that away before we go through it.
I know, I'm just saying, I'm looking at that and I feel like it looks like about 20%. I feel like it's gonna be right. I mean, you think about these squares, there's 5 rows, and I reckon that triangle is approximately one of them rows. Could be wrong. Maybe it's slightly smaller than one of the rows, so that's why I'm saying I reckon 18% is about right.
Okay.
Right, I better carry on in my race, otherwise I'm not being fair to true to myself. So we've got root 2 is the base of this triangle, and I'm looking at this triangle as 1, 2, 3, 4, 5. Okay, so I've got these lines going through. So I've got 1, 2, 3, 4.5 of those root 2's. Or I could write that, I guess, as 9/2 root 2. And that would be the height of my triangle. So half AB would be the formula for the area of a triangle. So I got half multiplied by 9/2 root 2 multiplied by, what did we say it was? Root 2. Oh, that's kind of nice. Area of shaded, that's going to be 9/4, and the root 2 times root 2 is 2. Yeah, that's okay to say that. So we've got 18/4, which is 4.5, right? Which, if you think about it, that's not quite 5. It's not quite a whole row. But we need to figure out what this is. So 4.5 out of 25. Gosh, did I get this right? That's the question. Oh, we got another one, 35%. I'm thinking based on this being 4.5, it has to be less than 25% at least. Let's have a look. Oh, I got 9. I mean, should I do that with a? I'm doing a calculation, obviously, but let's shake it up a bit. Times it by 2, 9/50. Get it out of 100. We've got 18. That's 18%. This is the shaded bit on top, and on the bottom is the total. So that's going to give us the percentage that's shaded. And I got 18%. I think some people here they got it good.
Okay, so
I think it's time to do your method, sir.
we had a couple of few answers, but I think 18% won. Lam Fung Lam Fung gave a bit of working out, which I can't fully
I
interpret.
reckon because there was it's connecting. I reckon because there was so much working out that it may have been the method you're about to do, maybe like three different if I'm right in what I think you're about to do.
Okay. All right. So let's see. So that was one method, and then there's another way to do this. Not better or worse, just different. Well, let's see if it works. So you could also look at the areas that are not shaded, as A just said, which are a little bit, the areas are slightly easier to work out. If you look at these triangles here, the lengths are 4 and 5. Same for this one. So those areas are going to be 20 divided by 2, or the length times the base divided by 2, which is 10. So those two areas, those shaded areas in blue, have an area of 10. This area is going to be a half. So for the, you could say non-shaded areas, you get an area of 10 plus a half, which is 20.5. And then you can work that out as a percentage, which is what? Let me write that as a fraction, actually.
I'm interested here. Mohammed said use Pythagoras theorem in this question. So that's super interesting.
41 over 2. Uh, 41 over 50. Oh, 82%.
That's the same as A. A
Yeah.
said that, yeah.
So that's the non-shaded areas, and then the shaded areas must be 18%. So is that what Lam Fung did? 5 times 5.
Not sure.
Oh, subtract. Yeah. Yes. Yeah. Lam Fung used the same workout. Well done. Awesome, guys. So it turns out if we just give you a little bit of time, you're like a bit of a, what do you call it? Like a
Firecrackers.
I'm having a blank. You know when that you're watching Who Wants to Be a Millionaire and they phone a friend,
Yeah.
or the on quiz shows,
A
what do they?
lifeline.
Sorry.
A lifeline.
Lifeline, yeah, something like that, yeah. Brains trust. Brains trust was the word I was looking for. But yeah. Good stuff.
Yeah, I love the interactions today. Well done, everyone.
I think we are going to end it there actually on a good note. That was the last question on irrationals that we had. So yeah, thanks for joining everyone. A few new names today, which is good to see. If anyone has any specific questions that they think we could answer, then feel free to put them in the chat. Otherwise, we'll start to kind of wind down. And if you want to join in next week, usually we go live on Tuesdays. Today was obviously a Thursday, but we'll maybe let you know if you prefer. We can kind of post on our community tabs when we're going live, or in the Discord. But yeah, I guess we're going to say either Tuesdays or Thursdays. All right. Any further questions? Tasnim, love these lives. Do more soon. Thank you. Yeah, well, we're going weekly. It seems we can keep up a weekly schedule, which is good. Next week, could you go through vectors questions where you have to work out the ratio that a line is divided into? Yeah, we'll try to include some vectors questions. That seems like a really popular topic that people want to revise, so we'll try to stick in some vectors questions every now and again. Thank you, Hamna. Alrighty. Solids and shapes. Alright, so I need some way to write this stuff down. Maybe in the, make a note in the Discord.
Yeah, I'll do it.
Solids and shapes. Vectors. Vectors with ratios. Alrighty. Okay. I think that's about it. I didn't see any other questions, so we'll see you all next week. Would love to see you again joining in. Alright. And also, remember, we also post videos. T-Formula posts videos on his channel, which are very useful for revision also. Alrighty. Thank you so much for joining us. And we'll see you next time. Bye for now.
Take care, everyone.